I work in the office of the Chief Technology Officer here at Autodesk, and my role is Explorer here at Autodesk, and that means that I'm supposed to be out looking in the dark corners for the things that will be meaningful to Autodesk in the long term, from the 10-year out to the 100-year out time frame. And that might sound a little crazy, especially those of us who have been here in Silicon Valley for so long, but it's really not that. And especially when we start thinking about some of the things we're going to talk about tonight, our origins, it's not so crazy because we're going to go way, way back in time. And I think it's super important for us to consider our origins because it truly does help us understand where we are going in the future. So, a little later, you are going to hear from my very good friend, Dr. Jill Tarter. Jill and I both are trustees at the SETI Institute. She'll talk a little bit about that during her talk, and both engaged at NASA in a variety of things, and you're just going to love hearing from her more about Jill a little later. Let's get started talking about origins tonight. So first of all, lots of origin stories here in our different cultures that you may be familiar with. The Garden of Eden, of course. There are many origin stories. Many different cultures over the years have come up with some really interesting and fascinating and fun origin stories. One of my favorites was always the Greek origin story with Kronos and Zeus and the Titans and Olympians and pretty crazy stuff captured here in this painting that you see here. Aboriginal Australian origin stories are kind of fascinating. But let's get down to the science. How many of you love science? Come on. Well, according to the meme, you effing love it. And many of you click on that a lot, apparently. So it's great that you love science because science is all about the search for truth. And we're always searching. We're always looking for that truth. And when it comes to our origins, there's so many exciting things that are still happening in that search. What you're looking at here is something that was just announced, 2 weeks ago, 3 weeks ago, found in Canada. This, if they are correct, it's all fresh, so we don't know for sure, but this is very exciting because this could be the earliest evidence of life ever found on planet Earth. Single-cell organisms from 4.28 billion years ago. The Earth is only 4.5 billion years old, 4.5 billion years old. And what that tells us is that life started on Earth very quickly after Earth started. And I think that's super important when we start thinking about the possibility of life beyond planet Earth. Let's take a quick trip now through time and talk a little bit about your origins. So this is, by the way, that's one of your great, et cetera, grandparents right there. And so is this little guy. These little trilobites from 570 million years ago. Amazing multicellular creatures that have been around for a long, long time. One of the activities out there, by the way, tonight, super fun. You get to take these molds and make chocolate trilobites. So go over and do that for sure tonight. Moving through time, we have the first fishes from 530 million years ago. And you all have an inner fish. Every single person in here has an inner fish. So again, one of your ancestors. And yes, even these guys, the first dinosaurs from 225 million years ago, and the first mammals from 200 million years ago. And of course, we're all mammals. So this is getting down a branch that is a little closer to us. And then finally, about 50 million years ago, the first primates. Starting with this little guy you see on the side over here, all the way up to this ape-like creature known as proconsul. We've not quite split off from some of our cousins just yet. That happened about 7 million years ago. So about 7 million years ago, something happened, and we took a very different path from some of the other things that became the apes and chimps, right? Everyone, and it got real busy after this, right? After 7 million years ago, we start going through some very interesting different branches on the tree, and we'll talk about branches in a minute. By the way, some of these skulls are out here on display for you to see tonight. So please go out and take a look at some of those. But we have Australopithecus africanus, afarensis, Australopithecus sediba. This one was only found in the last 10 or so years in South Africa by Lee Berger. Homo habilis, that's this guy right here. Homo habilis, the handyman. It was originally thought that Homo habilis was the first tool maker. This is a 3D printed tool, as a matter of fact, that'll be on display later that you can go out and see. Homo habilis was about 1.6, 1.7 million years ago, and then we found some evidence that the tools went back even further, close to 3 million years ago. So it turns out that not even the Homo species was necessarily the first of the tool makers here in our line. Homo naldi, just a few years ago, 3-4 years ago, this particular fellow was discovered also in South Africa by Lee Berger, the same person who discovered the one I just showed you before, of course, Homo erectus. By the way, do we have anybody here with Chinese or Korean ancestry? Some of you, you all have some Homo erectus DNA. All of you who do. Have any of you had your genes sequenced and checked that out? Has anybody done that with any of these other guys, the Homo denisovans or this one, Homo neanderthal? Some of you have some some Neanderthal. Anybody know their percentage? Ash, is that you raising your hand? What's your percentage? 3%. I have you beat. I'm 3.1%. Can you tell? Yeah. I'm surprised because I would have thought all Australians had more like 4%, because I know some of you. But yeah, all of us who are from Eurasia and Europe all have Homo neanderthal DNA in us. Of course, these guys were just discovered about 10 or so years ago. Homo floresiensis. These were the little hobbit creatures you might have read about. 55 pounds and 3 feet high. But they were Homo. They were human. They were just like us. We could get together with them and have babies that were able to reproduce. Don't know how else to put that. And then finally us, Homo sapien, modern humans. We've been around for about 200,000 years as a species. And what do we know? We know that all of us, every single one of us, came out of Africa. We are all Africans, period. That's it. We absolutely know that. The DNA tells us that. And humans, we're an amazing group. So about 100,000 years ago, we started moving out of Africa and spreading around the world, and there were only about 500,000 of us, Homo sapiens, anywhere. Homo at all, any humans. And then we spread around the world, and we went for about 90,000 years and never got over 1 million humans on planet Earth. Until about 10, 12,000 years ago, when we figured out how to do farming, and all of a sudden something amazing happened. We went from 1 million to 170 million in 10,000 years. So for 90,000 years, we were well under 1 million, and in 10,000 years, we went to 170 million, all because we figured out how to do GMOs. And that's true, because we learned how to, more or less, genetically modify things, and we made the world ours. And now we are the only species of human left. There are no more Homo neanderthals. They all faded out about 30,000 years ago, the rest of them. All of those other Homo species I talked about, within the last 100,000 years, they just sort of ended, and we were the only ones remaining. Of course, we've only learned this in the last 150 or so years, when this guy, Charles Darwin, jotted this down in his notebook, this amazing little diagram here, as he went out on that voyage and studied some of the animals around the world. And he came back and wrote about it, and of course he was ridiculed, and people say, no, 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 that can't be. Of course we're not related to those apes and monkeys. And even less than 100,000 years ago, we had this very famous trial here in the United States, the Scopes monkey trial, where we said, hey, you can't teach this crazy thing called evolution. So just in the last 100 years, we've started to shift. And interestingly enough, in just since 2009, the number of people in America, this is just in the US, who say, I don't believe in evolution, I believe in the Christian form of creation, that number has been going up since 2009. And I think that, like Neil deGrasse Tyson, that's a problem, and that we need to really take the science here and pay attention to that. Okay, we've all seen this before, right? Some version of this, and of course you've seen the new ones where the new guy on the end has a laptop and he's hunched over his desk, right? It's really not like this at all. And it's too bad that this ever got published and showed up in all the places it did, because it kind of gave everybody this impression that there was this kind of cute tree and it ended up going on a branch to orangutans, chimps, and gorillas. And by the way, there's two species of orangutans. There's one species of chimp and two species of gorilla in the world left today, and only the one species of human. But the reality of our tree is much more like this. It's really hardly a tree. It's more of a bush. There were lots of dead ends here. Nature tried all kinds of things to get to us over time. And more we're learning this as we find more and more evidence about where we came from. And in fact, it's very exciting what's happening still today. Much fascinating research is going on as we look into our human origins. And research into DNA as well. This is one of the reasons we know we all came from Africa right now, is because we have sequenced the human genome and we can go back to the Khoi and the San tribes of South Africa and find our very roots as human. Here's my very good friend. This is Professor Francis Thackeray. You guys got to go look up Francis Thackeray. And here's a funny thing. This is going to sound a little funny. You have to look up Francis Thackeray, Shakespeare, marijuana. Trust me, because it turns out he was the guy that they asked in London when they found one of Shakespeare's pipes to sequence the genetics and find out what was Shakespeare smoking. And he's come up with a theory, and you should go hear about what Francis has to say about Shakespeare. But let's hear from Francis right now.
Hello, Jonathan, and hello to all of you. Here we are in South Africa with fossils called Australopithecus africanus, about 2.5 million years old. We as paleontologists want to know, where did we come from? We know that we came from Africa, at least within the last 7 million years, and we have a diversity of species. What we want to know is how we are related to each other. These are intelligent beings that lived in Africa within the last 7 million years. This particular fossil, nicknamed Mrs. Ples, from the Stokefontein caves in the cradle of humankind in South Africa, it's, as I said, 2.5 million years old. And it's one of the many species which are related to humans. I personally believe that this individual would have represented a distant ancestor of all humankind. And I want to say one more thing about this particular fossil. It's 2.5 million years old. Now, if there was a form of life on the Andromeda Nebula 2.5 million light years away, and if that form of life had a really powerful telescope looking in the direction of South Africa, they would see now Australopithecus africanus walking upright and climbing in the trees. How about that?
Thank you, Francis. He's great. Go look up Francis. He's just an amazing guy. So how did we get here? So many interesting things happened. We learned how to control fire. Just as a matter of fact, about 30 miles away from where Francis is sitting right there at the Swartkrans Caves is where we have the earliest evidence of humans controlling fire, cooking our food. That made it so our intestines didn't have to be so big, which made it so our brains could get bigger. This was an amazing thing for us. And when our brains got bigger, all of a sudden we could make tools. And that was amazing. As a matter of fact, speaking of making tools, you'll see the 3D printed ones we have out there. This is Autodesk reality capture technology that you're seeing right here that I'll show you a little more about later in a project we're doing with someone in East Africa. It's exciting. When you think about origins here tonight, think about the origins of other things that we as humans do. The origins of art probably wasn't like this, but I like to think it might have been, because we found 42,000-year-old flutes made of ivory and bones from birds. People were making music 42,000 years ago. The Chauvet caves, 30,000 years ago, doing the first selfies. That's what this is. They would chew up red ochre, put their hand on the cave wall, and spit on it. Our design night team wanted to do that as an activity, but it was going to get a little messy. The Lascaux cave paintings, 20,000 years ago. The Venus of Willendorf. These things are all on display. Some of them out here for you to see tonight, by the way. 28,000 years ago. The Lion Man, 40,000 years ago. And the Makapansgat pebble, 3 million years ago. This is one of my favorite, and if you find me afterwards, I will talk to you about the Makapansgat pebble. I have one right over here, and I'll show you it, and it's awesome. Okay, so what are those guys thinking when they did that art? We don't know, and here's how we know we don't know for sure. If someone 40,000 years from now were finding this cover of the New Yorker, what would they think about us? Right? They'd come up with all kinds of crazy ideas. So who knows? We're trying to figure out what was in their minds. What would they think if they found this photo? How would they judge humanity 40,000 years in the future if they found this photo? Right? So why do we even care about all this stuff? Well, to answer that, I've asked another friend of mine. This is Louise Leakey. She just made this movie for us Monday. So, and thank you, Louise. And here she is, a good friend, Louise Leakey, from Turkana just a few days ago.
Jonathan, and hello to everybody here. First, let me start by introducing myself. I'm Louise Leakey, and I'm a paleoanthropologist. And my grandparents, Louis and Mary Leakey, and my parents, Meave and Richard Leakey, all devoted much of their lives to working up at Lake Turkana and other sites in East Africa, trying to find fossil evidence that help us understand our past and to study our origins. I'm actually at Lake Turkana. The sun is about to go down now, and this is the region where so many of the world's most well-known fossils that have been found over the past 50 or so years have actually come from deposits such as the ones that you can see in the background here. These are fossil deposits. They're laid down by the rivers and lakes that were in this region over the past 4 to 6 million years or thereabouts. And they contain lots of fossils, not only of those of our ancestors, which are very rare and quite difficult to find, but also of all the animals that lived and died in this region over the past 6 million or so years. So why do we study human origins? We study human origins really because it helps us find the fossil evidence to help us actually understand when certain landmarks in human origins actually happened. When did our ancestors walk upright on 2 legs? When did they make and use the very first stone tools that we see? When did they have an upright modern body plan such as we see in ourselves? And of course that very large brain that you see with our own species, Homo sapiens. Through studying our origins and looking back at our past, it really forces us to contemplate where we might be heading as a species. This, to me, really is the significance of studying human origins.
Thank you, Louise. We've been working with her to create africanfossils.org. You can all go there where you can see the computable models of the fossils that they find. She does all this work in the field and makes them all available. You can download them and 3D print them yourself. So something I think that's meaningful, because this brings this into every school in the world. And you can go out and see some of these 3D printed things here tonight as well. Okay, let's move on now to Jill. This is an exciting time to be thinking about the search for extraterrestrial intelligence and the origins of life. That's what astrobiology is. Here in our own solar system, so much going on around Mars. Did you know that if you were to melt all the water that's frozen in Mars, that you'd cover 20% of the planet with significant depth, right? Think there's life there? Was life there? Maybe. We should find out. And how about all the great news about TRAPPIST? She's going to talk to you a little bit about that. She is an absolutely amazing woman. You might be familiar with her work. How many of you have seen the movie Contact? Okay. So Jodie Foster's character is based on Jill in the movie Contact, right? She's the real deal. Her undergraduate work was in engineering physics. Her graduate degree, her master's and her PhD in astronomy. I don't know what to say about her other than I have so much respect for her, and lately I've been having a lot of fun with her, and I think you will too. So Jill, come on up and entertain the folks if you would, please.
Thank you. Thank you. All right, so let's get this oriented right, because Jonathan told me I could do it wrong and totally screw it up. So I think yes, you did. Very thoughtful. So let's talk about origins, and let's actually expand this concept of origins. And I'd like to point out that it takes a cosmos to make a human. And we are, in fact, made out of stardust. It's taken millennia for humans, scientists, to piece together this origin story of where we came from. And today, we're still continuing that journey because we're curious. We want to know who we are, why we are, what else there might be, and of course, who else might be out there. So over my career, there have been two phenomenal game changers that have completely altered the course of this journey: extremophiles and exoplanets. So extremophiles have shown us just how amazingly robust and inventive life in all its forms, starting from the microbes to the larger macroscopic animals and fossils that we collect. How amazingly adaptive life is. There's almost no place on this planet that doesn't have some kind of life. And I think we're still arguing a little bit about those most dry areas of the Atacama and whether there's no life or just that our instruments aren't sensitive enough to find what's there. But life is everywhere and gloriously diverse, particularly if you remember the microbes. And then exoplanets. They've opened our eyes to the potential for an enormous amount of habitable real estate out there that we didn't know about 20 years ago. When I went to school, there were 9 planets, and then there were 8, and that was it. And nobody knew whether there were planets around anybody else's sun. But in fact, today, we know that planets are plentiful. And just last month, we got this fantastic 7 Earth-sized worlds above the fold in the New York Times. Now that's saying something for exoplanets. And in spite of that lovely artist illustration of all those bodies, we've not seen these 7 worlds. But we know they're there. We can tell that they're there because we stare with our telescopes at the main star. And every once in a while, the light from that star dims because one of these bodies is passing across its face, casting a shadow and lowering the light that we receive. So just this, okay. I'm going to go on to the next slide. So this is an amazing system. 7 Earth-sized worlds, all orbiting a tiny little red dim star. That star is more like our planet Jupiter than it is like our sun. And here you can see this artist conception. I know I'm going out of camera, but for the people in the audience, this is the system in the scale of the inner part of our solar system, and it's blown up. So that's an incredibly compact set of worlds. And it encourages the artists down at JPL to ask, can you imagine what the night sky might be like if you were sitting on TRAPPIST-1e with all of those other Earths in your sky as well as your star. But, you know, this might be a wonderful place to visit, hence this tourist poster, but you really might not want to live there. But maybe somebody does. So this morning, in fact, at the SETI Institute, our scientists once again got up close and personal with, let's see if I can get this to play, with this TRAPPIST system. Okay, and now let's see if I can start it going fast. Right, so this is actually a good model of the system and the planets orbiting in it. And occasionally, such as 7:30 this morning, we get a conjunction where TRAPPIST-F and TRAPPIST-E, the yellow and the green planet, line up with the beam from our telescope looking at this. And so we decided, let's take a look to see if there's anybody shouting on TRAPPIST-F, on TRAPPIST-1F to somebody on 1E. And they'd have to have a pretty strong transmitter for us to hear them because the system is 40 light years away. But this is a special occasion, a special time that will repeat every few weeks. We will be able to do one of these conjunction experiments. And so that's what we're planning to do with this system, to see whether, in fact, there's any technology that we can discover. It didn't work, but you told me I can. That was Command Q. That's what you told me.
Help here, don't mind the guy behind the curtain.
All right, so here we are, we're back. So we will be going back to this star and taking a look when we get these conjunctions over the next year or so. And who knows? Perhaps there is someone on one planet talking to someone very close by on another planet in this incredible system. So we actually don't know whether any of these little red dim stars can hold on to an atmosphere. The planets orbiting these dim red stars can hold on to their atmosphere. To be the right temperature for something like liquid water, they have to be very close into their star. And that makes life a bit difficult, perhaps. But just last year, we found out that we don't have to just rely on the theorists and what they tell us about the ruggedness of planetary atmospheres orbiting red dwarf stars. The very, very closest star to our sun, Proxima Centauri, actually has an Earth-mass planet orbiting around it at the right distance, so it should be warm enough for liquid water if it can retain its atmosphere. So here, Mother Nature has just put this fantastic sandbox for us to play in, to explore. And so astronomers are rushing around trying to figure out how they can reconfigure existing instruments or quickly put together new instruments that could look at this unique, very, very closest planet to our own system and our sun. And so it's 4 light years away, and it may begin to answer these questions about whether or not planets around small, dim, red dwarf stars are potentially good abodes for life. And that's a very interesting question to ask because almost all stars are red dwarfs. Maybe 75% of the stars out there are much smaller and dimmer than our own star, the sun. So when we think about origins, those of us that work in astrobiology, we have a different perspective on the concept of here and now. And I think it's a really important perspective. We need to spend more of our time trying to share that perspective with you, with audiences, with everyone on the planet, including our political leaders who are going to help shape our near and long-term futures. Because this perspective matters. It really matters. So let me start by what we mean by here and now. Well, here, right, obviously, here we are, Autodesk Gallery. And that's in one market at San Francisco. And Google Earth has shown us that we're here, and now much of the world is getting comfortable with this perspective. From the altitude of low Earth satellites, we're here. And since 1968, we've been able to appreciate ourselves as being here. This is really our first cosmic perspective. A couple of years ago, Cassini, orbiting the planet Saturn, turned around, got the sun in just the right position behind the planet, and took a selfie of us, all of us. We're there. There's a little white dot. And I hope you read the memo and put on your best clothes and brushed your teeth and went out and waved at Cassini when it took this picture of us. Because all of us are there. And a bit earlier, in 1990, when the Voyager 1 spacecraft was on its way out of the solar system and it got to Neptune, it too turned around and took an image of us. And this is the pale blue dot image that has become so iconic. So we're here. And we're here. We're in the boondocks of a beautiful, large spiral galaxy. And our sun is only one of about 400 billion stars in that galaxy. And our galaxy is only one of about 200 billion galaxies in the observable universe. And there may be universes beyond. And as we look at this picture where those bright spots are not stars, but they're entire galaxies filled with hundreds of billions of stars, and we see that some of those spots are smaller and dimmer, we're reminded that as we look farther out in space, we're looking farther back in time. So that brings us to what do we mean by now, right? From this perspective, our now is the current epoch of a 13.8 billion year process of evolution by our galaxy. And most of us are not yet completely comfortable with this origin or creation myth that science is showing us. We're not even the scientists are completely comfortable with it because we've actually only seen about 4% of the total mass energy density of this universe. So cosmologists are struggling with dark energy, dark matter, and even gravity itself. And dark, that's just a code word. It means we don't have a clue. We don't understand these concepts. We can't point to this is dark matter. Here's a particle of it. Here's how it interacts with the rest of the universe. Or dark energy. Why should it be pushing things apart as gravity is trying to pull them together? Or maybe it's just that we actually don't understand gravity. So, nevertheless, this picture of here and now is the most self-consistent story that has yet been told about who we are and where we come from. And we tell it again, being fully cognizant of the fact that it may be subject to some future self-corrections. So we can stay with great certainty and confidence that the story of humans, the story of our origins, actually began billions of years ago in a fiery explosion of very massive stars that had turned the initial primordial elements of hydrogen and helium into all of the elements in the periodic table up to iron in the core of these massive stars that then blew up. And that debris, that stardust, reformed into molecular clouds of gas and dust that collapsed again into new stars and planets and perhaps life elsewhere. So we are intimately connected with those faraway places and times. And so here, tonight at Design Night, we really want to know if out there are others looking back at their long histories and perhaps asking the same question. Now, are we alone? And there's something called the Drake equation, which has been around for a while. Maybe some of you have encountered it. It's actually nothing more than a lovely way to organize our ignorance as we try and figure out how many communicating technologies might there be out there in the galaxy for us to find today. And we now know that almost all stars have planets, and that some of those planets are Earth-like. We know that some of them may be habitable. We don't yet know how many habitable planets have actually spawned life, and we don't know how much of that life may have given rise to intelligence and civilizations and technologies. But nevertheless, to within astrophysical accuracy, right? That equation truncates to this. The number of civilizations out there for us to detect is approximately equal to the longevity of their technologies in years. So, if L is small, if technologies out there, on average, turn themselves off, do themselves in a very short period of time, then there won't be anybody for us to find, and SETI won't succeed. But turn that around. If SETI finds a signal, if SETI finds some evidence of someone else's technology out there, then we know that on average, L is large. And we too can have a long future. And so we keep searching. We began our observational journey with radio telescopes 50 years ago. In the 2000s, we added optical searches to the mix. And yet, we've sampled very little of the cosmic ocean to date. There are 9 dimensions in which a signal could be hiding. And if you set that 9-dimensional volume equal to the volume of the oceans, then in 50 years, we've sampled about 1 12-ounce glass of water. So when people say, oh, they haven't found anything, they've been looking for 50 years, must be no one out there. No. It's a very big world out there, a very vast universe. And we are inspired to build bigger and better and faster equipment to conduct those searches. So at the SETI Institute, we've commissioned the first stage of the Allen Telescope Array in Northern California with 42 antennas. Now, this is the first time we've built a large telescope out of a large number of small dishes. And that makes silicon as important as aluminum and steel in this telescope. And in the future, improvements in the instrumentation lie not only in adding more dishes to get more collecting area and more sensitivity, but in taking advantage of the advances of Moore's law to get more and faster processing so that we can use the array in increasingly clever ways to search faster over these next few decades to explore a significant amount of that cosmic ocean. So SETI is one way that we could succeed in finding life beyond Earth. But along the way to that discovery, SETI also has a very important job to do, a job that can influence whether or not we actually have a long future, even if a signal is never found. The process of thinking about SETI, talking about SETI, actually conducting a global search, right? This all acts as a mirror to show us ourselves from a totally new perspective. A mirror that trivializes the differences among us. And so, this larger view of here and now that SETI encourages is really an excellent place to start tackling the challenges and finding solutions to the problems that we all face in our world today. Problems that do not respect national boundaries. We need to share this perspective. And you can start tonight or right now. Go on your social media devices and change your profile. Have the first thing that you say about yourself be that you're an earthling. That change of perspective can produce a meme that can be profound. And so I leave you with this gorgeous Earthrise image and the last word from Caleb Scharf. On a finite world, a cosmic perspective is not a luxury, it is a necessity. Thank you.